Okay, here's our last video where we're going to be talking about how to kind of go through these problems. So, selected values of the continuous function f are given in the table below. For -5 is less than x, which is less than 4, must there be a value c such that f of c is equal to 3? So this is a classic IVT problem. So first thing that we need to do is we need to state that our function is continuous. I know that it says it in the problem, but because IVT is what we're trying to use here, if we say by IVT, we need to have written down that it is continuous. So we're going to start it with f of x is continuous. This is really easy because it already told us in the problem. So f of x is continuous. Okay, now what we need to do is we need to see if our endpoints, -5 and 4, when we look at our table, that value 3 is in between them. So not only do we need to look at our table, but we need to write it down. So I'm going to go ahead and just say f of -5 and f of 4. So we need to find these two things. So I'm going to look at my table. When x is -5, f of x happens to be 7, so f of -5 equals 7. When x equals 4, our y value is 0, so f of 4 is equal to 0. So now that we have this, I can go ahead and make the statement 0 is less than 3, which is less than 7. We are now claiming that our y value that we were looking at is in between those endpoints. So our function is continuous and the value we want is in between our endpoints. So we know by IVT, or by the intermediate value theorem, we know that there exists a value c such that, or where, f of c equals 3. So, did we find what x value that is? No. It could be in between -5 and -2. It could be in between -2 and 1. It could be in between 1 and 4. We don't know, but that's not what this is asking. This is just asking, is there any possibility that this exists? And that's all IVT is. So let's look at another one. A car travels on a straight track during the time interval. Oh my lord. Those are not what I thought they were going to be. Those should be less thans. During the time interval 0 is less than t is less than 60 seconds, the car's velocity v measured in feet per second and acceleration a measured in feet per second are continuous functions. The table above shows selected values of these functions. For 0 is less than t is less than 60, must there be a time t when v of t is equal to -5? So this is the same thing. This actually gives us more information than we need. So you may notice it just says v of t equals -5. So a of t, we literally don't care about it. So just like before, we want to make that statement it is continuous. It tells us in the problem, and realistically, anytime we have something, if we have a table and it tells us it's continuous, then we're good to go. If it does not tell us it's continuous, we have to assume it's not. So v of t is continuous. Okay, now we need to look at v of 0 and v of 60. Okay, so when I am at a t value of 0, v of t happens to equal -20. So we get -20 for the top. On the other hand, when t equals 60, v of t is going to equal 10. We want a t value of -5, so -20 is less than -5, which is less than 10. So it is continuous, and our y value is in between the endpoints y values. So that means by IVT, there exists a value t where v of t equals -5. So the one thing that we want to be careful about is we're going to be learning multiple theorems where they are 3-letter combinations. So IVT. When we are doing this, we have to be really, really, really careful that we don't mix up the letters. So IVT, intermediate value theorem, if you're really worried about mixing up the letters, spell out intermediate value theorem. It's going to suck, but it's better than trying to mess up the letters. Okay, so the functions f and g are continuous for all real numbers, and g is strictly increasing. The table above gives values of the function that are selected, or that at selected values of x, the function h is given by h of x is equal to g of f of x. Explain why there must be a value r where 1 is less than r is less than 3, for 1 is less than r is less than 3, such that h of r is equal to 8. So this kind of goes back to that theorem that we were talking about a little bit ago, the continuity of a composition of functions. If a function g is continuous at c and a function f is continuous at g of c, then the composition of functions x and f of g of x is continuous at c. So as long as our functions are continuous over each other's intervals, then we are good to go. So f and g are both continuous over all real numbers. What this means is that we are continuous everywhere. So if I put one inside of the other, then we are still continuous. So this one we need to write just a little bit more. So we're going to say f of x and g of x are continuous. So g of f of x is continuous. If you want to go even farther, you could say after all of that, and h of x is continuous. Sometimes when we make claims, if we are not clear enough, then we can't really use that later on. Okay, now that we've claimed that they are continuous, we need to look at our endpoints. Our endpoints this time are 1 and 3. So we need to find h of 1 and h of 3. So let's start with h of 1. h of 1 is g of f of 1. So we need to find f of 1 first. So if we're looking here at x equals 1, f is equal to 6. So we are now looking at g of 6. When x equals 6, g of x equals 6. So when we are looking at h of 1, our y value there would be 6. Now, h of 3. This time we have g of f of 3. So when x is equal to 3, f of x happens to equal 10. Now we're going to look at g of 10. So when x is 10, g of x happens to be 11. So what we are looking at here is our y values are 6 and 11. So 6 is less than 8, which is less than 11. So we know by IVT there exists a value r such that h of r equals 8. So this is kind of what it looks like for IVT when we have a table. The only time it wouldn't work is if for some reason our endpoints are not giving us y values where our needed y value is in between them. Other than that, it's when it doesn't tell us if it's continuous or not. If we can't guarantee that it's continuous, we can't use IVT. Okay, we got these last two problems. So use IVT to determine if the following functions have a 0 on the given interval. So this is actually what most mathematicians would use IVT for, like application-wise, is if they didn't have a graphing calculator to kind of help them figure out where zeros were, they would then kind of create bounds and figure out where these zeros are. So what they might do is pick 2 points where they know a 0 is in between, figure out those values, and then try to narrow down their search. So we have our first one. F of x is equal to x cubed minus 2x plus 3. So thankfully, this is a polynomial. So f of x is a polynomial, which means it is continuous. So we have now made the continuous point. So now we need to plug in our interval to see if our y values will be good enough to have a 0 in between. So we need to do f of negative 2 and f of 0. So f of negative 2, we're going to go ahead and put negative 2 into our function. Negative 2 cubed is 8, but negative. Negative 2 times negative 2 gives us a positive 4 and 3. So if we add all of that together, we should get negative 1. Now if we look at 0, this one's nice. 0, 0. So 0 cubed minus 2 times 0 plus 3, we get 3. So our interval is negative 1 to 3. This is good for us because 0 is in between that. So negative 1 is less than 0, which is less than 3. So by IVT, we know there exists a value of x specifically between negative 2 and 0, where f of x equals 0. So this one, we had to remind ourselves that we were looking for a 0 of a function, which just means our y value is 0. Otherwise, it is exactly the same as the table. We just might have to do a little bit more algebra than before. Okay, our last one. F of x is equal to x cubed minus 2x squared minus x plus 2. So thankfully, this is also a polynomial. So this function is continuous. Okay, so we need to plug in our two endpoints, f of 3 and f of 4. This one takes a little bit more because they are just more x values. So 3 cubed, 3 squared, and 3. Okay, so 3 cubed happens to be 27. 3 squared is 9, and 9 times 2 is 18. Okay, 27 minus 18 minus 3 plus 2 gives us 8. Now we are going to look at f of 4. Same thing, but plugging in 4. Okay, 4 cubed is 64. 4 squared is 16 times 2 is 32. Minus 4 plus 2. All that together is 30. Okay, so here is what we know. We have two positive numbers and we need a 0. So 0 is not between 8, and 30. So we do not have enough information to use IVT. Okay, so this is kind of like what IVT is used for, just kind of deciding if something exists or not. It's not finding what it is. We didn't actually figure out any of the X values that would make these things occur. We just figured if we could figure it out. So thanks for watching this video. So excited that you guys were sticking out to the end. Don't forget to like, subscribe, and hit that notification button.